We will now use the facade design pattern to remove the complexity associated with the usage of these APIs. We will add a new project. Let's make it the starter project. And we will close this file. And the first thing I'll do is add a class that will act as the facade over these APIs. The name of this class will be console. And we will provide one static method to the user that will be used for writing colored text to the console. So we'll add this function called write. This will accept a string and it will also accept a color. So for color, I'm going to create an enum. Note that we will only deal with foreground colors. So these are the 4 colors that this console class will support. The default color will be white. So this will simply write the text with the specified color on the console, but it will not add a new line. To write the text with a new line, we will provide this function called writeLine. That's it. The client will only see these 2 functions. And internally in the console, we will need a couple of attributes. First of all, we will need the handle. This will be the handle to the console. And we'll need the Windows header file. This handle is static because we want to access it in these static member functions. And the reason for using inline here is to avoid having to initialize this handle in console.cpp. But for this inline static feature, I will have to enable C++17. We will change the language standard to C++17. If you do not have a C++17 compiler, then you can always use the C++98 style of initialization for this static member variable. And then we will need this screen buffer info variable. And we will also create a single instance of this console. For this static instance, I cannot use inline static feature, so I will have to initialize it outside the class. Let's synthesize these functions. And we will also need constructor and a destructor. In the constructor, we will have to store the information of the console, and we will restore that information in the destructor. We will initialize the console handle, and then we will get the information of the console. And if this function fails, we will throw an exception. And in the destructor, we should restore the console information. Now we will implement the write function. First, we need to get the information of the console. We will have to create another variable here. So we'll need to store the console buffer information before applying the color to the console. Let's copy this. We'll need it here. This console buffer info member variable is required for restoring the console information just before the program exits. And this is a local variable which is required for restoring the console information just after we write the text with a specified color. Next, we need to set the color. And here we have to pass the color that corresponds to this enum. We cannot pass this enum directly here. So for this, I'm going to write a helper function. And the default will be to return white color. We need to OR red, green, and blue to get the white color. That's it. We can now invoke this getColor function from here. The return type of getColor should be simply word rather than dword. And obviously, getColor needs to be static. Next, we'll declare a variable of type dword, and then we will write the text onto the console. And finally, we should restore the console screen buffer info. That's it. This finishes implementation of the write method. For write line, all we have to do is just invoke write like this. This finishes the implementation of the console class. That's all for now, but in the next video we will see how to use the console class to write colored text onto the screen.